We begin today's session with the topic data-driven research with data types, scaling, and survey methods. We have with us Dr. Kuldeep Kumar, is an associate professor at Amity School of Architecture Planning with extensive academic and industry experience in the field of fire safety and construction management. His expertise encompasses data-driven research, methodologies, approach, quantitative management, and analysis-based approaches in architecture and the built environment. He has significant experience in integrating statistical and analytical techniques into architectural research, enabling informed decision-making and research-oriented problem-solving. He has actively contributed to academia through teaching, research guidance, and different research initiatives, encouraging the applications of analytical tools and scientific methods in architectural studies. His session focuses on bridging the theoretical concepts with practical applications, helping researchers, academicians develop the structured and impactful research framework. I request Sir to take over the proceedings. Thank you, sir.
Thank you, ma'am, for the introduction. Am I audible?
Yeah, yes, sir.
And is the screen visible, ma'am?
Yes, sir. Yes, sir. Please go ahead.
Yes. So good morning, everyone. I am Dr. Kuldeep Kumar, Associate Professor at Amity School of Architecture and Planning. Welcome to this session. So as we know that the theme of this FDP is blueprint to breakthrough. So this is a beautiful architectural metaphor. In architecture, blueprint is beginning, intention, the plan, and the breakthrough is the result. So the building that stands the knowledge that changes the practice. So before any architectural researcher go from blueprint to breakthrough, they need to answer one foundational question. What kind of data am I working with? And how do I collect it properly? So today's session called data-driven research, that is data types, scaling, and survey methods. So these three topics or three terms are backbone of any empirical research in architecture. So, and these are it's very important to understand them. So let's begin. So this is the session roadmap for today. Part 1, it's quick but important introduction to research in architecture. It's like, why does it matter and what kind of methods exist? Part 2 would be types of data. That means, what are you measuring? Is it qualitative or quantitative? Is it nominal, scale, or ratio? Part 3 would be measurement and scaling methods. That means, how do you turn perceptions or attitudes and observations into numbers? Part 4 would be survey methods. It's like, how do you collect data from people and places? So let's talk about in brief that what is the research means in architecture. So most of us must have conducted research, and there is one of the most common problem in architecture research, that there is a disconnect between doing and knowing. Research methodology is often treated as like a paperwork rather than a process that shapes your entire inquiry. So in this context, there are several definitions, but the important definition which I could find out is that the research is defined as the careful, systematic, patient study and investigation in some field of knowledge that is undertaken to establish the facts of principles. Now notice these three words: careful, systematic, and patient. That means there is no rush, no intuitive, and you cannot say that I know this from experience. So it has to be systematic. Now, as we know that architecture has historically been driven by intuitions, aesthetics, and the expertise of practitioners. And there is nothing wrong in that. However, in these days or in 21st century, we are expected to be evidence-based practitioners. So where it is important that the research methodology and the process of research comes in. So research in architecture serves three major purposes. One is evidence-based design, second is problem identification, and third is knowledge generation. In evidence-based design, it's like moving from I think this work to the studies that shows that this works. So like from subjective assumption to the objective knowledge. So this is what architecture credibility in a multiple disciplinary maybe conservation with engineers, policymakers, and other stakeholders. And number two is problem identification. So here the research helps us to identify the real felt problems, not imagined ones. So like what do the residents of any building want? What makes the school unsafe? And what does the thermal comfort occurs? How does the thermal comfort occurs? Like, and last is the knowledge generation. This is knowledge generation is basically comes from published research that creates a knowledge base, and that on that others can build upon. So when you publish a study like maybe on post occupancy valuation of affordable housing in your city, so you are actually adding a brick in the wall of the architectural knowledge. So that this is why that is important. So now moving to the part of this today's session which is considered to be most fundamental and important as well. So I want to basically begin with the statement that one should understand what you are measuring before deciding how to measure it. So that what is very important. This sounds actually simple, but many times it happens that where the data was collected in one form and then analyzed using the method that was not actually compatible with that form. So understanding the data is not merely a paperwork. It's not even a formality. So it's an intellectual foundation of your entire research design. Now this is actually the big picture, how the data is classified. So data can be classified in three ways, and each answering a different question. Number one is by source. That means where does the data come from? So if is the data you collected yourself for the first time, then that means it's a primary data. Or if the data that is already existing or it is collected by someone else, that is called as secondary data. The second classification is by nature or by characteristic of the data. So that means what kind of information it is. Is it descriptive or categorical? So we are talking about things that cannot be meaningfully expressed on numbers. That means it is a qualitative data. On the other hand, the data can be numerical, things that can be counted or measured. That is known as quantitative data. So again, quantitative or qualitative data has subtypes. So qualitative data has two subtypes, that is nominal and ordinal. Qualitative data has two types, discrete and continuous. We'll see this in detail in subsequent slides. Third is by scale. That means measurement scale, how precisely it can be measured. So this is actually developed way back in 1946 by Stevens framework, which is called as NOIR, N-O-I-R, nominal ordinal interval ratio. So let's see each of it. So first is data by source. Now coming to the primary data. So primary data, as we have said, you collect yourself directly from the field, from respondents, and from physical measurements, which is specific to your research. So now how the primary data is collected. So the methods are many and varied, and you will recognize all of them, but actually to your own needs. It's like you can get the primary data from telephonic interviews, from direct observations, behavioral mapping, field surveys, questionnaires, and from post-occupancy evaluation, physical measurements, and also from focused group discussions. So each of these methods like puts the researcher directly in contact with the phenomenon being studied. So this means that is the specific to your study. Now let's see the advantages. The biggest advantage of this primary data is that it is specific to your study, to your research inquiry. There is no ambiguity about what was measured and how, because you have done it. The data, and the another advantage is that the data is current, it's latest. And overall, through your research, you are controlling it also. The quality of the data you are controlling. As far as limitations are concerned, there are few. So because now you have to go, you have to collect. So primary data is expensive in time, in money, and in efforts also, because field visit requires travel and you have to carry equipment. Sometimes access to many buildings and communities may be restricted, and you may navigate ethical requirements also, like informed consent, privacy, community permissions. So these are kind of limitations. So if you look at the few examples which are pertaining to the architectural domain, so where primary data can be used is like a thermal comfort survey conducted across say 150 hostel rooms in summer. So there the primary data is useful. Maybe a pedestrian volume count on a commercial street, or maybe post-occupancy interviews with residents on a new housing schemes. So something like that. So overall, we can see that primary data is most rigorous and most form of the evidence. So let's go to the next. Now coming to the secondary data, it is the data which already exists. So it is collected previously by someone else, or maybe for a different purpose, which you reuse or reanalyze to answer your new research question. So think of it this way, that when a government of India conducts the census, they collect data on population, household, amenities, and housing condition across every ward in every city. But when you conduct your research, so you use it to analyze housing density patterns in maybe in a heritage neighborhood. So that means you are using the secondary data which is already there. So now, where does this secondary data come from? So this data comes from maybe published research papers or academic journals, historical maps, census or demographic records, newspaper archives, building bylaws, master plans, or maybe condition reports, some from the state government, etc. So let's see the advantages of secondary data. Now, compared to primary data, it is quickly and cheaply available, or already the large data sets are already compiled and in a clean format. Also, it is invaluable for historical comparison, like understanding how the place has changed over time. So it actually provides a baseline data against which your primary findings can be benchmarked. So with this, there are few limitations also. So it is also possible that data may not correctly match with your research question, because it was done for some other purpose, as because it was designed for some other purpose, and it may be outdated also. You cannot also not verify it, because from where it was collected originally. And also the definitions used by the original researcher may differ from yours. So there are few limitations also. Examples which are relevant to architecture domain, like using municipal corporation ward level population data to study the housing demand, or maybe using published post-occupancy studies from other institutions as a comparative benchmarks, maybe, or accessing archaeological survey of India records for any heritage documentation study, something like that. So a best research is basically both, often uses both primary and secondary data together, because as we can see that secondary data establish the context and the baseline, and primary data provides the precise problem specific evidence. So we move forward to now the second way of classifying data, which is by nature or by characteristic. So one question may come to your mind, that is the data descriptive or categorical, or it is numerical or measurable? So this is the distinction between a qualitative data and quantitative data. Now let's see the quantitative data. So let's see the qualitative data. So as the name occurs, it describes the qualities, that is attributes that cannot be meaningfully expressed as numbers. But it actually answers the questions like what is the type, what is the category, these kind of answers which we get from this data. Or qualitative data is always categorical. It places things into groups or ranks. Uh, it also have two subtypes like nominal and ordinal. So nominal data is like categories, it provides the categories but with no order. So the word nominal comes from actually the Latin word nomen, meaning the name. So nominal data gives the name of the categories like building typologies. It may be residential, commercial, or it can give the name to the material, concrete, steel, timber, or maybe the ownership type, PPP, or government trust, etc. Any heritage status. So there is no implied ranking or order in among these categories. Here, just think that, can you say that residential is more than commercial? No, we cannot. Similarly, you cannot calculate the average of building use type. It is not of no use. The only statistical operation on the nominal data is it same or different? Nothing more than that. Coming to the ordinal data, so it categorizes with the meaningful order but unequal gaps. The order would be there, but the gaps are still not equal. So ordinal data actually rank things, and we know that one category is better than or higher than or more than another, but we don't know the precise distance or gap between the categories as far as ordinal data is concerned. Like in architectural example, if we see that condition of any building, so we can say that the condition is excellent, condition is poor or very poor, or any walkable level on a street, that the level is low or high. Similarly, the level of traffic, maybe user satisfaction also. So the ordinal data just tell about the order of this. So here we know that the grade 1 is more significant than grade 2, but is the grade 1 exactly twice significant as the grade 2? That may not be the case. Similarly, is the gap from poor to fair is the same as the gap from good to excellent? We don't know. The gap may be unequal. So this is a kind of limitation with ordinal data. Let's see the quantitative data. So it is expressed as numbers, unlike the qualitative data. It is obtained through counting or measuring, and it answers that how many or how much or how far somebody is. Also, the quantitative data is numerical in a meaningful way. You can perform like arithmetic calculations, you can find out averages, you can find out correlations, and apply a full range of statistical techniques in this area. So it also have two subtypes. One is discrete and other is continuous. So discrete data is like it is counted in whole number only. Discrete data like can only take specific whole numbers. You can count it. It cannot be taken as like into fractions or decimals. So that value in the discrete data has to be distinct, like number of floors in the building. Number of floors are 3, 5, 12, etc. Number of rooms in a dwelling unit. Number of windows in a facade, or maybe number of parking spaces in a layout, like that. So you can see that you cannot have 2.3 floors, or you cannot have like 3.7 windows in a facade. So the value in the discrete data has to be a whole number. Simply, we can say that if you count it, it is discrete. Very simple. Now let's see the continuous data. So continuous data is measured any value on the scale. So now we know that theoretically there are infinite possibilities of values between 2 points. So you can take any value along the spectrum, including the decimals, fractions, like floor area in a room. So it can be in points, maybe 143.75 meter square. Building height, it can be 26.6 meters, or daylighting level, lux level, or maybe indoor temperature, it can be 32.4 degree, like this. So we can simply say that about the continuous data, that if you measure it, it's continuous, right? So you count the number in a count the number of a room in a flat, it's discrete. But you measure the area of the room in a square meter, it's continuous. That is the basic difference. So it's a overall full comparison on screen to see that both the data families side by side. So if you see the nature, qualitative data, as we have seen that it is descriptive, categorical, and non-numerical. And for quantitative, it is numerical and measurable. See, subtypes we have seen. So the answers are very important, which we get from qualitative. It's like what is the type and which is the category. Then the data is qualitative. And when you talk about numbers, how many, how much, how far, it tells about the number or numericals. It is qualitative. So simply like that, now we can see that the last one, the qualitative data is best used for describing patterns, categories, and experiences, wherein quantitative data is best in measuring magnitude, testing hypotheses, and generalizing the findings across the population. And here, what I think it is important, that it is important to note the most credible research in our field uses both. So you describe with qualitative data and you measure with quantitative data, right? So I'll repeat, you describe with qualitative data and you measure with quantitative data. So now you can see together both these data build the argument in both rich and rigorous way. So coming to the next, about the scales of measurement. Actually, this was introduced by psychologist Stevens way back in 1940s, and still this is used in research worldwide. So coming to the nominal scale, which is the most basic level of measurement. So the only information it carries is, are these two things same or different, just like this, but it is like the identity only of any data. So we'll compare these these data: nominal, ordinal, internal, and ratio across the 4 parameters. So here in nominal, we just have the identity. We can only distinguish the categories from each other in this case. We don't have magnitude, equal intervals, and true zero, which we will see in the later slides. So like identity in the examples like residential, commercial, or institutional, it is kind of building type. So it is just the identity of a particular type, like ownership, private government, and or maybe the facing of your building. So all of these are actually labels and not natural ranking. So we can easily say that brick is not more than concrete. We cannot say that. Residential is not greater than commercial. They are simply different. So what you can do with nominal data is that you can count the frequency of each category. You can find the mode, the most common category. You can draw those charts, pie charts, and what you cannot do is, because ranking is not there, so you cannot rank, you cannot calculate the mean, you cannot calculate the median, or you cannot perform any arithmetic calculation with the nominal scale data. Now let's move to the ordinal scale. So it builds on nominal. So now you can see the second attribute is also there. So this adds to a new property, that is order. So that is why it is called ordinal. Identify plus ordinal, plus order is ordinal. So ordinal scale adds one critical property to the nominal one, that is the meaningful ranking. Now we know that the categories are different, but now they are some higher or lower than others. So now ranking is also included in ordinal. Uh, Maybe we can see this at a satisfaction scale. Like 1 is very dissatisfied, 2 is dissatisfied, 3 is neutral, 4 is satisfied, and 5th is very satisfied. So we clearly know that 5 is better than 4, 4 is better than 3. So the ranking is real and meaningful here. But the gap between neutral to satisfied, or or maybe the gap between satisfied to neutral may not be the same. We don't know that. It might be or it might not be. So that is the basic fundamental limitation with the ordinal data. Ranking is there, but gap is not equal. If we see the examples of the ordinal scale, like building conditions, okay, condition is excellent, or it is dilapidated, or it is excellent, so something like that. And maybe we can see that, like in heritage grading, grade 1 is more significant than grade 2, but maybe the cultural distance between them not be quantifiable in equal steps. So what kind of, now we see the statistics allowed in ordinal data. Now we can calculate the medians, we can calculate the percentiles, we can do the correlation. So you can easily say that the median condition rating is fair. It is easily, we can say that in this case. So it's now coming to the scale 3, that is interval. Now it is building upon the ordinal. So now identify is there, order is there, now equal gaps. So interval, so the interval scale also includes the equal gaps. So the classic example of interval gaps is the temperature in degree Celsius, we all know. So the gap between 10 degree to 20 degree is exactly same bit as from 20 to 30 degree, equal interval, that is 10 degree. But note that 0 degree does not mean that there is no temperature, right? It is simply the freezing point of the water, or maybe a reference point. And critically you cannot say that 40 degree temperature is twice hot as 20 degree. We'll see through this through examples like of the interval scale. Indoor temperature, maybe in classrooms it is measured in degree Celsius. Year of construction, like the year of construction, the gap from maybe 1960 to 1980 is exactly 20 years, and the same as from 1980 to 2000. But there is no year 0 in architecture. So statistic allowed in this interval scale are, you can find out mean, standard deviation, variance, correlations, analysis of variance you can do. So all parametric statistical toolkit can be done. Now coming to the last, ratio scale. So here the last, all properties plus true zero is also involved in this ratio scale, right? So maybe we can see this through example. So maybe like the building of 200 meter square is twice the size of 100 meter square. So this is a valid comparison, right? The building height of 0 meter, no building. So now the true 0 is there. Here 0 is meaningful. If somebody says the building height is 0, that means there is no building at all. The room has 0 windows. That means no windows. So the absence of windows is real in this case. Now, example of maybe the ratio scale in context of architecture can be that floor are measured in meter square, building height are in meters, volume in meter square. So it is more about the units which we are using. Weight of the structural material in kgs, number of floors. So typically, almost all physical measurements in architecture are ratio scale. So let's see let us put together everything in most practical slide of the entire section. I've tried to do that. So now this is because this is useful pertaining to your research question which you are carrying out. So let me read the question. Question 1 is, what material are used in the facade of heritage building on the street? So Now the data type is qualitative, scale is nominal, and the suitable analysis will be the frequency count or the pie chart. So as you are only categorizing it and not ranking it. Similarly, question 2, how do residents rate the quality of their housing? So definitely it's talking about quality. The data type is qualitative. It is ordinal as we are rating here. And as far as suitable analysis is there, the satisfaction rating can be done through median or bar chart or correlation can be done. Now let's take another example. See, if you say that what is the floor area of each dwelling unit in this housing scheme, if you say that. So it is, because now you're talking about the areas, talking about the numbers. So it is the quantitative, and the ratio is quantitative and continuous ratio scale. And then analysis can be done analyzing the mean of floor area or standard deviation, according to which we are aiming at in our research. And the next one, what is the orientation of building in this block? So it is qualitative, because the orientation, it is just telling about the orientation. The scale is nominal, and the frequency table here in the suitable analysis can be the frequency table, or maybe because this is about the climate, a rose diagram for wind or solar analysis can be done. Now one thing you notice that how these are different from each other. The research question completely determines the data type, the scale, and the analysis method. So that is why understanding of data type is not optional. It is the foundational thing that everything else sets on. So before we move to the next part, that is the scaling method, let's summarize what we have seen in the types of data, or these are the takeaways. Takeaway 1, always identify your data first. It determines every subsequent analytical decision, like which scale to use, which statistical test to apply. If you get this wrong at the start, then the error will cascade throughout your entire study. Takeaway 2 is that primary data is collected by you, secondary data is collected by someone else, but both are valid and both are valuable. And your choice should depend on the research purpose or the timeline and the resource, and not like this, that which is better in the abstract. Takeaway 3, qualitative data describes the categories, quantitative data describes the numbers. So it is important that architectural research uses both, and it is seen that strongest studies done uses them in the combination to reinforce the foundings. Takeaway 4, so as we have seen, discrete data can be counted, like number of rooms, number of floors or windows, and continuous data can be measured. So there is a difference. Discrete is counted and continuous data is measured, like height, temperature, like that. Okay, if you count it, it's discrete. If you measure it, it's continuous. So takeaway 5 is the 4 scales which we have seen: nominal, ordinal, interval, ratio. Higher scale means more information and more powerful analytical tools can be used. It's simple. And the last takeaway, it's important, never collapse your data to a lower scale unnecessarily. Like for example, measuring in square meter is always better than measuring in small, medium, or large, because that do not give you the correct data, right? So do not unnecessarily lower the scale. Similarly, measuring in degrees Celsius is always better than measuring in, if you say that it is warm, hot, and cold. So be specific in this case. So next, let's move to the next part. Just wait a second. So coming to the scaling techniques. Now we have seen this, but what is scaling? So we'll see this with the help of example. So scaling is basically typically defined as the process of placing respondents on a continuum with respect to their attitude towards the issue being studied. right? It's a placing of respondents on a continuum. So let's discuss the full journey of from a raw feeling to a research finding using using a pedestrian safety example. So step one in scaling is for particular example we are taking raw response. Like if a pedestrian says, I feel unsafe when I walk through this underpass at night. So this is qualitative, descriptive, and valuable. But yet there is no scale to analyze it. You cannot analyze. Now see the second step when you apply the scale. So what we can do, we can hand over a card on a scale 1 to 5. We can ask that where one is very unsafe and 5 is very safe. So how you will rate your safety in that underpass? So maybe she or he can mark 2 in that. So number 3. So now scaling has been done. Number 3, data has to be generated. So we collect the similar data from maybe 200 respondents. So then after collecting the data, the mean safety score comes out to be, may say 2.4 out of 5. Now data is also there. The next part is to analyze the data. Now we know from literature that maybe because the benchmark must have been done, we are assuming that from literature, the score below say 3.0 out of 5 is not acceptable. So now the analysis is done that now it is not safe. So step 5 is decision on whatever analysis we have done through the data generated, what we can do. So decision can be made through our findings that justifies a specific design intervention like better lighting or active ground frontages, installation of CCTV cameras, or removing the blind corners. So the decision is also now on the basis of analysis. So that is the power of scaling. The feeling of become a finding, a perception becomes a policy recommendation, right? So when a feeling become a finding, the perception become a policy maker. That is the whole beauty of the scaling that we have seen. Now we begin with the most widely used scaling technique in architectural and social research. So the Likert scale is named after an American psychologist, Rennis Likert, who introduced this in 1932. So let's see this in detail. So a Likert scale is defined as a psychometric scale that commonly involved in research questionnaires, asking respondents to specify their level of agreement or disagreement on a scale of series of settlement of a specific research. So the classic format which we know that 1 is strongly disagree, 2nd is disagree, 3 is neutral, 4 is agree, and 5 is strongly disagree. So the respondents mark I think we should see with the example of a library. So this is an example of post-occupancy evaluation of a library where the premise is that the spatial layout of the library promotes focus study. Now let's see how this works. So the respondent marks one of the 5 options after collecting the response from all users. You calculate the mean score and the distribution, and you can compare across the building users. So how the Likert scale is constructed? First, we can see step 1, prepare a comprehensive list of statements about the attitude or attitude object. Include a mix of positive and negative statements. This helps in detecting inconsistent respondents. So remember that it should include mix of both positive and negative statements. Step 2, each statement is rated on a scale of 1 to 5 from strongly disagree to strongly agree. Step number 3, item must be clearly positive or clearly negative in direction. Avoid being putting neutral and ambiguous statements. Step 4, it's better to conduct a item analysis. Calculate the correlation between each item score and total score, right? Each item score and total score, the correlation, then it is always better. And step 5 is sum all the item scores per the respondent, and the total, and hence the total Likert score of the respondents will be the overall attitude which we were looking at from the initial hypothesis or in hypothesis premise we have taken. The spatial layout of the library promotes the focus study. Now, here it is important to understand that where is the Likert scale used in architectural research? Because it is very specific where we can use it. Like we can use it in maybe user satisfaction in public spaces, parks, library, or streetscapes. You can use it in perceived safety surveys in neighborhoods, post-occupancy evaluation of any building type, accessibility and barrier-free design assessment, or maybe in thermal and visual comfort studies. So here there are, I think, two critical rules which we have to remember, that Likert data is technically ordinal data, but when in practice, when you have 5 or 7 point and reasonable large sample, so this may be treated as interval data for purpose of calculating means. So this is also acceptable convention. And the second important part is that always use odd number of points, so that there is a genuine neutral point in between, right? Coming to the other kind of scale, which is semantic differential scale. So this I consider as the most elegant in social research, and as well as it is best suited in architectural research also. So this technique does not ask how much or how many. It simply asks, what does this space means to you, right? And it's measure the meaning through the language of opposites, which we'll see in the slides, right? Now this is the example. So let us define it first. Semantic differential scale is defined as the technique that requires a respondent to rate a concept on a bipolar adjective scale, right? I'm repeating, bipolar adjective scales. That is the main concept of semantic differential scale. So these measures 3 dimensions: evaluation of the scale, potency of the data which have, and the activity. Evaluation, like, is it good or bad? Is it pleasant or unpleasant? So these are bipolar scales. Potency means that is it strong or weak? Is it large or small? Heavy or light? And activity includes whether it is active or passive, fast or slow, dynamic or static. So now you can see these pair or these attributes, these are bipolar. And that's what I was saying, the language of opposites. So together, these 3 dimensions which we have talking about, evaluation, potency, and activity, capture a rich and multi-layered picture of how people experience their space on or building. So here is an example. So we are rating the experience maybe of a heritage building facade. Each row represent a pair of opposite adjectives that we have seen. So the respondent marks on the point of 7 as per his experience, like first one. So beautiful or ugly, respondent marks 6. That means leaning towards the beautiful. In modern or traditional, respondent marks 2. That means strongly traditional. Similarly, for light or heavy, respondent mark 3. So it's slightly light. Or for maybe last, well-maintained or deteriorated, respondent mark 5. So that means fairly well ventilated. So now let's consider, say, about 120 respondents are considered for this. So when you average these scores and plot them on a graph, so you get a semantic profile of that. So it's a visual, maybe visual fingerprint on how that building experienced. So you can compare this profile across the building, and you can also track changes after the conservation interventions have been applied. Also, it is also important that this scale is uniquely powerful in our domain. So it captures the subjective experience dimension of space, something which a questionnaire cannot do. Like subjective experiential dimension, questionnaire cannot do that. It allows comparative studies across the buildings. Also, it can track the changes of perception after design intervention, as we have seen it in that heritage example. It is ideal for senses of places studies like neighborhood image research or aesthetic quality assessment. So it is advised that the choose the adjective pairs carefully. They must be genuinely bipolar or culturally appropriate and relevant to your research context. Or it is also advised that pre-test them before you go through the target pollution, because irrelevant and confusing pairs genuinely reduce the validity of your scale. Now the next one is rating scale and ranking scale. So now we will cover the two essential scaling techniques. Number one is rating and second is ranking. So rating scale uh, asks respondent to rate each item independently on a numerical or descriptive scale. Here, uh, each object is judged on its own merit and not in comparison with others. So there are two types of rating scales: graphic rating scale and itemized rating scale. In graphic scale, in this scale, like the respondent mark a point on a continuous line with between two extremes. So this allowed fine gradation in the response, because like you have a maybe 10 centimeter line or line, and where the respondent is marking his or her response. So it can vary from extremely comfortable to maybe extremely uncomfortable. So there are fine gradation can happen in the graphic rating scale. And itemized rating scale, it is most commonly used in architectural research. So here the respondent chooses from the set of labeled category, like, because we have labeled the categories, like rate the daylighting adequacy in the classroom. So you have the categories like it is fully adequated, partially adequated, or inadequate, or rate the overall building condition, poor, very poor. Unlike the rating is already fixed, and there in the graphic scale there are a lot of possibilities on which rating can be done. So this is also again very useful in our domain. And on the other hand, in the ranking scale ask the respondents to arrange the items in the order of their preference or importance. Right? I'll repeat. In ranking scale, the respondent are asked to arrange the items in the order of their preference. Now it is their perception to how the criticality of each item is this. So it shows us that what matters the most, but now by how much. So what matters the most is the most important part in the ranking scale. So these are of three types. These are of two types, sorry. Simple ranking and pair ranking. Simple ranking is like assign ranking 1, 2, 3 to all items from most to least preferred. This process is very quick. And paired comparison may compare each possible pair of items. This scale gives the preference that this item is preferred over the another item. But this paired comparison is more rigorous but more time consuming as well. So it depends on your research or your requirement where you can intervene in this. And as far as examples are concerned for ranking scales, so maybe you can use it in community participation of a survey of redesign of neighborhood park, like you can ask that please rank the following features in order of your importance. So these parameters can be safety, seating, greenery, lighting, accessibility, and shading. Now, the respondent has to arrange these parameters as per his or her uh, preference. So in case, now let's take an example. In case if safety consistently rank first across across say 300 respondents, so that is the powerful finding, and that directly shapes your future research or maybe your design brief which you are working on. So this is exactly how evidence based designs works, right? So to summarize, we can see that what is the key difference in ranking and rating. So the rating tells you about how good item is on its own. Ranking tells you which items is preferred over other. Both are valuable, as we can see. The choice depends on whether you need absolute assessment or relative priority. So moving to the next scale. So the Gutman scale is based on the simple idea that all the attitudes forms a hierarchy. Think of it like a staircase that you cannot go to a step 5 without having passed through step 1, 2, 3, 4, 5. So it works on that process. So Gutman scale is a basically a cumulative scale where items are arranged in an increasing order of their intensity. And so we can see that agreement of a higher intensive item or a harder item implies that agreement with all easier items below it is already done. Or item 1, so we can see through this example. So item 1, let's see, suppose the building has a step-free entrance, agree. Now second is building has a accessible toilet on the ground floor, agree. Item 3, building has a lift or ramp on the floor, agree. Suppose these are kind of example which which were asked, maybe asked by respondent in a survey. Or all circulation path, agree. But the last one, wayfinding includes tactile indicators and braille signages, or there is a disagree. Now the building scores 4 out of 5, it is clear. Now here is the critical insight that because it is a cumulative scale, the score of 4 tells you exactly which item of the building complies with and which does not. So because we are assessing the accessibility, or we are seeing the compliance. So this score tells you the complete profile. So this is the power of Gutman scaling. It produces unambiguous or diagnostic information and not just a summary of numbers. So we can take an example like in a universal design compliance audit of maybe a educational institutional. So this is applicable. This can also be applicable for say fire safety checklist for building. It can also be used in progressive accessibility grading of public transport infrastructure. So we have now covered the main scaling techniques, but knowing which scale to use it's still not sufficient. More important is to ensure that your scale actually works, that it produces the data that is trustworthy. That is more important. So this brings us to the two most important quality test of measuring instrument, that is validity and reliability. So a measuring instrument is reliable if it produces consistent results, correct? And it's valid if it actually measures what it is intended to measure. So therefore both are essential. And you can say that if validity is concerned, validity asks, am I measuring the right thing? So there are three types of validity. that one should know. Number one is content validity, criterion validity, and construct validity. So let's see one by one. Content validity is that does the scale covers all aspects of concept you are trying to measure, right? For example, if you're measuring a thermal comfort, but your questionnaire only asks about temperature and not about the humidity, air movement, or radial heat, so your scale has low content validity. And in the criterion validity, does your scale correlate with the established external measure or standard, any standard? Suppose if your perceived safety scale gives you low score in that particular area, and that also have high crime statistic in that particular area, that means it is demonstrating that uh, criterion validity is there. So it is matching with already existing benchmarks or already existing the standards. Construct validity is that does the scale behave as the theory predicts? For example, if the theory says that better lighting should improve perceived safety scores, and your score when you were doing this, your score or your scale shows the pattern, yes, after lighting intervention this improves. So that means it's a construct validity is there and it's high. Now coming to the reliability. So reliability asks, do I get consistent results? So there are three type of reliability tests, where test retest, split half reliability, and internal consistency. So test reset, test retest reliability means it administer the same scale to the same group twice, a fewer week apart. So if the score correlates strongly, the scale is reliable because we are giving the same scale to the same group, but again. And split half reliability is divide your scale into two half and compare the score on in each half. A strong correlation will indicate this reliability. And the internal consistency is generally measured by Cronbach alpha. This test is basically done through SPSS tool. A value of alpha above maybe 0.7 is generally considered as acceptable. So this tells about the reliability of the data which you are using. And this internal consistency is the most commonly reported reliability which is measured in all the researches, right? So here is an analogy which I can share, that a broken clock is reliable because it consistently shows a wrong time, but it is not valid because it does not tells you the correct time, right? Because we know that the clock is broken, it's not reliable. So to summarize this, a good scale must be both consistently measuring the right thing. Now let's see which scale is, these are kind of examples, which scale is suited where. Uh, let me give you the most practical, examples in that. So let's take the first question. If you want to measure user satisfaction or opinion in a post-occupancy evaluation study, so we'll see that which scale to be used. So the most appropriate scale is Likert scale, 5 or 7 point, because it is simple to administer it is, and people are familiar. It is familiar to respondents, and it produces data that can be statistically analyzed. In another example, if I want to measure the architectural character or the sense of a place, of a building or a neighborhood, so here the most appropriate scale is semantic differential scale. So now we remember that bipolar adjective pair that captures the experienced and multidimensional quality that a Likert scale cannot. In another example, if you want to grade, say, physical conditions of any building, so Here the rating scale is most useful. It is itemized as per the questions which has to be asked. So it is better that rate each building element independently on a consistent categorical scale in the rating scale. In this case, when you want to grade the physical condition. And the last example, if you want to audit the compliance of a, say, heritage standard like accessibility or universal design. So here the most suited one is the Gutman cumulative scale, because its reproducibility means that each score maps to an exact compliance profile, because we know that what are the parameters which are compliant. So it makes it ideal for audit and regulatory purposes. So now, before closing this scaling one and moving to the next, I would like to say that the choice of scaling technique is not a minor methodological detail. It actually shapes the quality of your data, the type of analysis you can perform, and the conclusion you can actually draw. So choose the scale deliberately, and which are based on your research questions. So moving to the last part of today's, excuse me. So now this is the last part of today's FTP, which is survey methods and architecture. Survey method in architecture. So here, as of now, we have established that what kind of data we are working with and how to create measurement instruments. Now the question is, how do we actually go out and collect the data? So here, survey methods are, basically the systematic approaches where we can gather information from people on sites, or we can gather information from documents. And especially in architecture domain, surveys are not just about the questionnaires. They incorporate wide range of field work and approaches, some similar approaches. So let us start the most common method used in surveys, questionnaire survey. So as we all know, that questionnaire survey is a structured set of written questions given to respondents to collect data systematically. It can be administered in person or by mail or by phone, or you can do it online. So types of questions which are generally asked, incorporated in a questionnaire are open-ended question, close-ended question, a scaled question, and dichotomous question. Open-ended question, as the name suggests, these questions allow the respondents to write their own answers in their own words. For example, what do you like most about this neighborhood? If this is a question. So this question will generate rich textual data, but it is harder to analyze statistically. So these open-ended questions are best used when you want to capture the diversity of experience and you have a manageable sample size. The close-ended questions, these provides fixed options like multiple choice. These are fixed, yes, no, or tick boxes. So these are easy to quantify and analyze. Like, for example, question like, do you feel safe in this neighborhood? So it's simple, it will ask yes, no, or sometimes. Just that. Third is a scaled question. So combining what we have scaled is, we have already learned what we have learned about scaling. So scaled questions are like done on Likert, rating, and rating, as this already discussed in previous section. So these are actually the backbones of a quantitative questionnaire research. And the last one is dichotomous questions. So here there are only two options. These include binary answers. Questions such as, is the building accessible to a wheelchair? So this question will ask simply yes or no, nothing else. And the examples where these this questionnaire can be used in our architecture domain, like perception of a heritage building conservation quality, user satisfaction in public parks or transit stations, thermal and visual comfort studies, barrier-free accessibilities, and maybe pedestrian experience. Like, and here one more one important advice which I would like to share, that always pilot test your questionnaire before deploying it to the full sample, because definitely you will invariably discover questions that are confusing and ambiguous and inappropriate. So pilot testing is very much required, is very much required. So it also, pilot test also saves you from collecting useless data. So beyond questionnaires, there are two most valuable survey methods in maybe in architecture and other fields, that are interviews and observation. So interview surveys, as the name suggests, essentially it's a face-to-face, or can be done through phone, can be done through videos. So questionnaire, these are questionnaire, but here the important thing is that it will add with critical addition of the researcher's ability, so that to probe and clarify, to follow the unexpected threats, because the researcher is asking those questions. So it is his ability to to intervene during the interviews. So these interview surveys are of three types: structured, semi-structured, and unstructured. Structured interviews, that follows a fixed script, same questions, same order for every respondent, and this produces the data which is directly comparable across the respondents. It is basically, it is used when you need to analyze a pattern across a large sample. So say, and the semi-structured interviews, so these have fixed themes and key questions, but there is a chance, and there is a provision, the researcher can rephrase or skip or add question based on the conversation. So this is most useful, most commonly used in architectural research, because it balances depth with the consistency. And the last one is unstructured interviews. So these are open-ended conversation with the minimal predetermined structure. So these are basically used in, say, exploratory research, when you do not yet know that what question are most important. So these type of interviews are most common in early stage of ethnographic work. So examples can include, example of this interview survey can include interviewing residents about walkability, talking to traditional craftsmen about construction techniques, conducting expert interviews, and like this. Now, on the other hand, in observation survey, the researcher watches and record behavior or the physical condition rather than asking questions. So these are of four types: participant observation, non-participant observation, controlled observation, and uncontrolled observation. So in participant observation, the researcher joins the group which is to be studied. Imagine that you are living in a housing colony for 2 weeks just to understand the socio-economic of the dynamics. That is the participant observation. Non-participant observation, where the researcher watches it from outside, like sitting in the park and mapping where the people sit, stand, walk, and where the activities they are doing. Controlled observation, here the survey is done in a structured and managed setting. For example, a user test but in a mock-up room. So it is controlled, the environmental is controlled, and everything is structured, survey is structured. In uncontrolled observation, in this case, the survey is done in a natural or unmanipulated setting, because this is the most common used in field architectural field work. So behavioral mapping in public spaces is one example. This can also include tracking of pedestrian movement in retail complexes. Observing queue behavior in transport hub can also be an example, etc. Now we have talked about what to survey. Now whom do you survey? Let's have an overview of this also. So we never survey everyone in the population. Instead, you select a sample and which is a subset of the population that is representative of the whole. So sampling method falls in two families: probability sample and non-probability sample. So in probability sample, every member of the population has a known non-zero probability of being selected. So this allows the researcher to make statistically valid inferences. Now let's see the types of these probability sample. Number one is simple random sampling. Here, every individual has equal chance for selection. It's a kind of lottery method. So it is best for a small accessible population. You can do that. Second is systematic sampling. So we select every nth person from the list, such as selecting like every fifth house on a street for a survey. It's simple and structured as well. Third is stratified sample. In this type of sampling, you divide the population into a meaningful groups, that is strata, maybe by building age, income level, or building type. So it ensures representation across each group. And the last one, the cluster sampling. So here it randomly selects clusters like cities, blocks, wards, buildings, and then survey everyone with the selected clusters. So this is very efficient for maybe geographical and dispersed population. Now, on the other hand, non-probability sample, here the selection is not random. It is easier and cheaper, but limitation is that you cannot make statistical inferences with the same confidence as you can do with this probability sampling. Non-probability sample can be categorized in 4 parts. First is purposive sample. Name suggests where the researcher deliberately selects individuals with a specific characteristic, like you need to interview architects with 10 years of experience in a heritage conservation. So it's a purpose that you have selected a particular category. Second is snowball sampling. Here, the existing participants, they can refer the researcher to new participant, and it is very excellent for hard to reach population because reference is needed, such as homeless communities, traditional craftsmen, or historical building owners. Useful for that. Third is convenience sample. As the name suggests, sampling is done with whosoever is available or willing. It is also fast and cheap and potentially biased. But it is potentially biased because you conveniently you have selected the sample. So there are chances of biasness in the sample. Last is quota sampling. In this sampling, the numerical data has been set for subgroups. Then the sampling can be done non-randomly with each group. Like you select 50 males and 50 female respondents selected from a particular sample. Right? But now in all this sampling, it is very important to note that the stratified or purposive sampling is most appropriate depending on whether the researcher is doing his qualitative or quantitative research, right? So there is a one key rule which you can follow, that your sample must be large enough to be representative, but manageable also within your time and budget constraint. That is the key rule. It should be large enough, but manageable also. So before we conclude this and to reach to the summary, so I have just compiled and it in the form of summary. These 6 principles that should govern all the data research in data collection in research. One is validity. So that was validity of scale. This is validity of data. So validity means, are you measuring what you intend to measure? If your research question is about spatial comfort, so your questionnaire must actually capture the comfort, not just the temperature, right? Second is reliability. So if you administer the same instrument twice to the same group and under the same condition, so would you get the same result? So there are high chances, high reliability, then that means low error. Third is objectivity. So your data should reflect reality, not your expectation. Because your expectation can be different, but it should reflect the reality. Use standardized protocols, and it is always good that you remove leading questions from your questionnaire, right? Fourth is adequacy. We have talked about it. Collect enough data to draw meaningful conclusion. Because a satisfaction survey with 8 respondents in a house of 500 families may not be adequate. So there are statistical formulas to determine minimum sample sizes that can be used. Fifth is timelessness. Data must be current. But the old data is not relevant, no? So it has to be latest in this case. Like using 2001 census data in 2024 or 25 is actually questionable. So always consider the temporal relevance in your data sources. Last, 6 is ethics. Remember that this ethics is non-negotiable in research. Obtain informed consent from all participants. Be especially careful while surveying vulnerable groups like slum residents, children, people with disability, and communities in conflict. So key takeaways, before I conclude, key takeaways from this session. Number one, I'm again repeating it. Always identify the data type first. It is qualitative or quantitative or nominal ratio. Remember, this single decision shapes your subsequent methodology choice, including the statistics which you're going to use. Takeaway 2, the scale of measurement. From nominal to ratio, it determines the various analytical possibilities which you can use in the research. Takeaway 3, scaling methods. And this is how you convert human perceptions, attitudes, opinions into a measurable and comparable data. For this, Likert scale, semantic differential scale, and other techniques are precision instruments. Use them deliberately. Takeaway 4 is the survey method. This must be matched carefully to your sample. Because what you are doing, it should be matched with that. Your survey method, your resources, your timeline, and your research question. That is most important. Remember that there is no single best method in this case. A well-designed or mixed method approach is always good. Takeaway 5, this is the last one. Good data collection is valid, reliable, adequate, timely, and ethical. Right. So last but not the least, there are no shortcuts in research. Trust me, shortcut here will compromise the entire essence of your research. So with this, I will close my talk, and these are the references. Thank you so much, and thank you for listening to me. Thank you, ma'am.
Thank you, sir, for such an
Thank you, sir.
enriching session.
Should I stop sharing, ma'am?
Yes, sir. Thank you so much for insightful and enriching session on the integrity of the data types with measurements and scaling types and survey methods. I am sure this session has truly enriched our understanding of research methodologies and data-driven approaches. I would like to, we shall now move towards the QA session. Now I'd like to invite Lavditya Khurana to take over the session for the question answer. Participants are requested to actively participate and clarify their queries. Thank you.
Thank you so much, ma'am. Thank you so much, sir, for an intriguing presentation today. It was very, very informative, and I'm sure a lot of our participants would benefit from it. So, and I'm sure this faculty development program in itself, having such sessions, makes it clear that the landscape of architectural research is basically shifting. Now we understand that we've moved beyond intuition-based design into a sophisticated era of design-driven inquiry. Therefore, now I request and I inform that the floor is now open for questions and any other discussions. I request the participants, both offline and online, to kindly switch on their microphones in case they want to ask any questions, and also share some key points of discussions if they have any. Do we have any questions? Yes, sir. We have a question from Varish, sir.
Good afternoon, everybody. First of all, thank you, Kuldeep sir. It was a very insightful presentation. I have a question which I think is pertaining to our field, architecture. Most of us as researchers often find this, that there are a lot of experiences like comfort, when we want to measure identity or sense of place, terms that we often use. And we often find them difficult to measure when we are conducting any kind of research based on these parameters. So how can a data-driven research method address these qualitative aspects effectively? That is my question.
Okay, sir. Very valid question, sir. So when you are talking about experiences like comfort, identify, so I would suggest that mixed method approaches are more relevant, that can be combined with say surveys, interviews, or observation, and maybe can be with kind of qualitative architectural experiences, including the case studies, right? So in this case, I think rating scales and behavioral mapping helps will convert because you are talking about very subjective thing. It's experience. So rating scales is a essence in this case. Subjective experience. So rating scales and behavioral mapping will help in converting the subjective experience like comfort, identity into a measurable data. Correct?
Yes.
And also the last point which I would like, that data should be interpreted on with like social, cultural, and environmental context to actually reflect the human spatial experience in this case, right? Because I think that answers your question, sir.
Yes, sir, definitely. Thank you so much, sir.
Thank you.
Thank you so much, sir. And I would also like to ask one question here. Sir, you mentioned about various sample sizes. We were talking about various sample sizes in your presentation that were required and the techniques in which we can select one sample size for a particular research project, let's say. My question revolves around the fact that are there any factors specifically aligned to select or, to select the correct sample size, or what is considered to be a considerable sample size, let's say for a building level or even at an urban scale? Is there any considerable factors that we have to keep in mind?
Sir, very open-ended question, sir. Because you're talking about from building to urban scale, right? So, very valid question again. So, actually, sir, the sample size, it depends on your research scope. Number one, what kind of research inquiry you have depends on the population size, the diversity of respondents, and which is involved in your study. But there is a term called central limit theorem. According to the central limit theorem, if there is some kind of expertise required, So minimum of 30 respondents is generally acceptable for basic statistical analysis, not big sample size. Correct? Like if you are going for a study like fire safety, so you cannot ask anyone about the fire safety. So you need experts for that. So in that, minimum 30 experts you need. It cannot work with 2 or 3 or 4 or 5, right? So central limit theorem is sacrosanct in that term. And your second question was that, sir, about the urban part, right?
Yes, sir.
So it also depends what kind of study you are doing. As far as my knowledge is concerned, minimum 100 to 120 respondents are required to in this case. But actually there is a formula, sir. If you put your population size and your area and whatever, it will give you the exact sample sizes required. But minimum, just in the urban context, minimum 100 is required.
Thank you so much, sir. As we move forward with the concluding remarks of today's FDP, the session 1, I'm sure we all have understood in today's presentation that, sir, in fact, Dr. Kuldeep Kumar helped us navigate that that there is an intricate process, basically, of integrating diverse types of data, from qualitative spatial experiences to quantitative environmental metrics, and by bridging the gap between measurement and scaling techniques and traditional survey methods as well, we hope to be now better be equipped with transforming this raw observations into rigorous and evidence-based architectural insights. Now, the goal of this session for everyone, our participants over here, was not just to introduce tools, but to refine the lens through which we view our built environment. And as educators and researchers, our ability to apply these methodologies will definitely define the accuracy and impact of future architectural discourse. And I would like to thank all of our participants also to be patiently sitting here, and also some people who are online connected with us. We look forward to seeing all these techniques find their way into our studios or our different research projects as well. And thank you so much, Kuldeep sir, for answering our questions and making our doubts and clearing our doubts as well.
Thank you, sir. Thank you. Thank you, everyone, for listening to me patiently.
Thank you, sir.
Thank you, sir.
Thank you, ma'am.
So, all the participants, the next session will be start from 2 p.m. onwards on emerging technologies in research, role of AI and data analytics and architectural research. So be there. We'll forward to see you all in the second half. Thank you. Good afternoon, everyone. We shall now move to the next session. The session is on AI and data analytics and architecture research by Dr. Niharika Kushwaha. Dr. Niharika Kushwaha is a postdoctoral researcher and a faculty member at American University at Sharjah with a PhD in sustainable city planning. Her academic and research work focuses on developing resilient urban environments that promote sustainable, inclusive, and equitable growth. She has actively involved in interdisciplinary research and government collaborations related to AI-driven system, urban analytics, and data management for enhancing urban quality life. Her work explores the application of emerging technologies in shaping future-ready cities by improving urban decision-making processes. Dr. Kushwaha research interests lie at the intersection of urbanism, technology, human experience, with a strong emphasis on the integrating qualitative research, psychology, and lived experience into a data-informed planning and design framework. Her work contributes significantly to advancing innovation, human-centric approaches in sustainable urban development. Now, I invite Dr. Niharika Kushwaha to kindly take over the session. Ma'am?
Yeah, hi. Thank you, Dr. Snigdha, for the introduction. It's always good to be back to your alma mater to present out good sessions among my seniors and mentors in this FDP. Is my screen visible, ma'am? And I hope my audio and video is okay, right? Okay. So good afternoon, everyone. And thank you for being here and joining us for this session of the FDP. Today's session, I'll try to focus on emerging technologies, specifically artificial intelligence and data analytics in the field of architectural research. In this session, I'll walk through the evolving research workflows, let's say from problem framing to visualization, and discuss how AI is influencing each stage of our architectural inquiry. A brief and kind introduction has already been given by Dr. Snigdha, and adding on to it, I would like to very briefly talk about where my role specifically to this session belongs is that understanding data analytics in its integration with AI. For this FDP, you would have heard in last few sessions, and you would be hearing in the coming sessions about the architectural research workflow, the data methods, techniques that happens out there. I'll try my best to focus specifically onto this niche topic of AI into architectural journey. And I feel I am blessed to have this opportunity because over the course of years, my work engagements are focused on integrating how these digital methods and architectural tools are being integrated with AI and how they can actually be a good friend to us and support in data visualization, decision making, and any kind of innovative principles that we need to design on the built environment disciplines. So starting briefly with, I hope my slides are moving or not. Are my slides moving, ma'am?
Yeah. It's moving.
It's moving. Oh, I can't see onto it. Let me just reshare my screen. I can't see my screen moving onto it. Just a second. Let me try again. Yeah, okay. So let's start with understanding what is AI. AI means very different depending on the kind of perspective you have. Let's say if it's for the students, it's something that is a shortcut for assignments. For faculty, usually we see like students are working on ChatGPT and other kind of methods, and they have got the assignments done. But faculty is smart enough to understand it has taken the help of some kind of an AI tool. Whereas for faculties, it's they feel it's a threat to originality. They feel that over the course of time, these tools are kind of taking students away from the creativity aspect. The students are not able to comprehend that it is a tool that is supporting out their intelligence rather than competing with their intelligence. And for researchers, but for the tech industry, it's the future. So that's why a lot of AI tools are coming up in today's time to these architectural research areas. Name it from BIM to Autodesk. So many other tools have been come up in this category. For researchers, it's a tool that needs validation. As researchers, it's inbuilt into us that we ask a lot of questions: how, why, uh, what kind. We need validation, and that's why while working with AI, this integrated nature of ours help it to particularly move forward with utilizing the tool in a much better efficiency. And at the end, AI in itself is something that calls that I am something I'm based on available data. AI is what you give into it. It takes a lot of data from the internet server, from different background webs that it is working along with, the interconnected aspects of data networking. But till the time you do not ask the right question to AI, it doesn't actually move forward with giving you the right responses as well. Just a second. Apologies for the same. I guess my presentation is stuck. I can't see my slides moving. Maybe you guys are able to see, but I don't know. Just can someone confirm if the slides are moving? I'm still stuck on slide 1 on my end. Oh, yeah, now they're moving. Yeah, great. Okay. So let's talk where the AI actually plays a role in architecture. Historically, architectural research suffered from limited access to data. We do not belong to STEM disciplines. Today, the opposite is true. We used to see people from STEM disciplines having a lot of available data to them, and they were doing some experiments in the labs. Either the computer engineering people were working around with it. But with architecture, it was a very different category. In order to collect that much amount of data was a different story altogether. But now it's totally opposite of it. Today, the thing is that the researchers can now evaluate, I would say, thousands of possibilities and simultaneously based on your architectural parameters. Here, what you can see here are the examples of dashboards. Let's say on the left-hand side, we have this dashboard where you have n number of data from air quality, noise level, traffic count, different organization working on different parameters. But then it is the challenge becomes the extraction, the intelligence extraction, how well you put it, what is the need of what kind of data is needed for your research, how do you visualize it, how do you represent it. That becomes the essential aspect of understanding AI's role in architectural research. So instead, the creativity now needs to shift from the descriptive kind of research that we have been doing to understanding what are the better parameters we can input into AI, asking sharper questions so that we get the best of the responses from it, and making very informed choices within these complex systems of AI. Hence, I would take a second and say that at times we say that it's human versus AI. No, that's definitely not the case. AI is not changing architecture, AI is not taking our jobs, but definitely it is changing how we know architecture. It is the human intelligence that is being augmented by the computational intelligence nowadays. And AI can process at the information at enormous scale. Even something it's beyond our imagination, the scale and speed of AI nowadays. But the interpretation, the ethics, the contextual understanding, and meaningful judgment still becomes fundamentally human responsibilities. So on that note, I would like to take this session forward, where we do look onto these tools, we do look onto how they help us in our research workflow, but keep in mind that at the forefront of it lies our own judgment, our own understanding, and our own creative input into these tools. So initially, when we talk about the evolution of architectural research, traditionally it has been presented always to us as a linear process, and moreover as a descriptive one. We do literature review, we do methodology analysis, then we do the conclusion, give out our final results. And that's a flow that always will be there because that's a research flow we follow. But with architecture, it differs a little bit. It become in practice, the architectural research is really linear. I'm sure researchers who are currently working in the field, researchers who are pursuing PhD, and even faculties who are working with students on different kind of architectural research, they would agree to the point that for us, architectural research is very iterative and recursive. We need to go back and forth to the points. And AI intensifies this iteration. So initially, we transformed from traditional to digital. Okay, we had some data, we had laptops, computers come in, they could perform certain analysis and all. Then came the computational part, where just rather than informing through digital and analytical data, we could perform certain predictive scenarios and could say, okay, this might happen, this can happen based on the data that we have found. Right now, we are in the generation of AI enabled where we say it needs to be adaptive and generative. And when I say adaptive and generative, that is the stage that we significantly talk about in architectural research, which requires greater speed and greater depth that is provided by the AI. And how it is provided by the AI, let's understand it with first a very basic thing. We all have moved from CAD to BIM, parametric architecture. Let's take an example of Rhino as a software, and we understood over the course of years when the noise of BIM started, we understood it's a parametric software, Grasshopper that can plugged into Rhino. Rhino can also be worked around with Photoshop, AutoCAD, or you can develop a laser cut physical model by giving in the right commands and everything. The fabrication workflow worked well. Now, similarly, for AI, let's say it's an interconnected tech loop. It does not operate in isolation. For architectural research, it exists within a large ecosystem of these intelligent research technologies. This slide actually further emphasizes my point when where AI is embedded within a broader technological infrastructure. Spatial data sets and regional context given by GIS. You already have BIM that can help you to develop onto the lifecycle management and integrated data. For data analytics, you have n number of softwares working with performance analysis. And specific to the architecture field is the computational design, where you can give algorithmic geometry and performance optimization. So this is where it says that over the course of years, architecture research pedagogy has evolved very drastically, and I would say at a very fast speed. Even like for my PhD, it's not been too long, but within those 2-3 years after my PhD and till the time I'm working on these research projects, I have learned so many tools. I used to feel AI was something, yeah, initially you get scared of these things. Initially you feel it's an enemy of yours. You're just not able to understand what kind of a tool this is, what all it can give. I have the knowledge after doing the research. But while using these tools, they have become my best friends. And through this session, I'll try to use this platform to give a little bit of insights into some of these tools. As I said earlier, there are n number of tools, but we'll try to touch upon few of them. And they are the current emerging technologies in the field of our architectural research. Now, understanding firstly why AI in architectural research, why do we need it? AI, everyone used to feel, is something that was working good with the computer engineers, was working good in the field of management. The MBA people needed because they had a lot of data analytics, everything. We, on the other hand, were working more towards the qualitative depth. We understand things with different perspectives as architects. That's how we have grown. But it's important to understand that our architectural domain also has a lot of complexities that we need to deal with. Starting with the three major reasons why AI is in architectural research, an important one. The first one being the urban complexity. Cities today, they face interconnected challenges, name it from housing to climate change, mobility, infrastructure, socioeconomic inequality. They are just not social or urban issues, but there is n number of data that is available for you to input and understand and recognize your own patterns of how a urban complexity of a city or an area is working. That's where AI can help you. Secondly, because there is a rise of multi-layered data into our research. We now work with satellite imagery. We are working with sensor networks. We have GIS layers of different parameters. We have mobility data sets. We have behavior information simultaneously. We have observations from our own site observations, site surveys. So we have a lot of data that needs to make sense in a proper way. That is where AI can help you. And lastly is the need for predictive and analytical thinking. Uh, as I said earlier, research is moving far from description towards more of forecasting, optimization, scenario simulation. And that's where architecture becomes more interdisciplinary. It's not just architecture. You have social perspectives, you have computers, you have data into it, you have something from the psychology side, you also have something from the environmental end, from the built environment end. It's such a vast field that all these data needs to be operationalized, but at the same time, they need to be reduced the complexity computationally. We cannot handle that much for data. So that's where AI comes into the form. Let's start with, you would have understood the research flow and everything in the last few days, and even in the today's session, as Dr. Kuldeep mentioned, you have these scaling techniques, you have data methods. But all those things before we talked about definitely problem reframing. Now, what is problem framing? We understand it in a basic language as a research question. Whenever any PhD committee sits and asks you about your research, till the end of your semesters, they're talking about a research question. Even in the field, when you are submitting your papers, the whole point, the whole aspect of your research focuses on to what kind of research question are you targeting and what is it that you are trying to answer. So AI contributes in itself to the problem framing. The shift here is from linear reading to more network understanding. How do you develop that research question? Earlier, it was like, we are no longer asking, what does this paper say? That is how we used to read it. Literature review, okay, this paper, we read it. These are the points this paper is asking, etc. and etc. But now we need to ask, where does this paper sit within a very large knowledge system? That is your research domain. And it's not a very niche area. Of course, it gets to that niche area when you start developing your topic. But initially, with the problem framing, you need to see where your research problem lies. And AI contributes to the problem framing in two major ways. The first one being gap discovery. The NLP models, the natural language processing models, they scan thousands of publications to identify the missing themes, and they can help you to formulate a clear PhD level research questions. The second one is synthetic logic. When I say synthetic logic, it means that researchers can connect fragmented information into a very structural framework. So that helps you to move from just your hunches to a very data verified synthesis, that where the constraint lies. What kind of research is being talked about? What are the pros and cons of it? Where does my research domain is divided into? What are these topics? Is it for my topic? Is it against my topic? All these areas are being supported by certain AI tools. However, this stage also requires caution. AI is very, very good at exposing vague thinking. I'm sure, like, almost everyone would have tried on ChatGPT, Gemini, Perplexity, some very common tools, putting out a prompt out there. And while putting out a prompt, initially, you would have been frustrated at a certain point. It is not giving you the right thing you are asking for. So that is why, because AI is very good at exposing your vague thinking. It just picks that you are not asking the right question to you, and then that's the area where the lack of the question clarity, the outputs from the AI become more superficial or misleading. So AI should be supporting your critical thinking, not replacing it. That is where AI can help very nicely in a good problem framing. Let's look at some of these tools. I'm sure Research Rabbit is something most of you would have heard about or even worked around with. It's a useful tool for literature discovery. Instead of traditional keyword search, it helps you to create these visualization citation networks. Researchers can see how authors, papers, themes, they are all interconnected over time. And it transforms the literature review into a more exploratory and visual process. If you would remember, like few years back, this is how the literature review used to go. You find a paper, you go to their references, you see the references that are there, and then you try to find out those papers, and that is how the connections we used to make and see what kind of papers were applicable to our research. We used to read the abstract. Okay, this abstract fits into my research. This is a paper I'll be taking into. This is might be a secondary level paper for my research. Let's keep it onto another folder, etc., etc. This is automatically done by Research Rabbit. You can create your own library here. You can divide out what kind of thematic clusters you want, or you want to have a temporal research over the course of years, what's being talked about it, or you want to go by author by author. Certain authors who have worked into specific topics, concepts, research papers related to their field, and what changes have been there uh, in the work of these authors over the years. All of those things can be given out by Research Rabbit. That's why it's now one of the primary AI tools that's being used even by the students in their architectural research. The next one being Elicit. Now, what Elicit does, it functions as a semantic assistant. It can extract very specific claims, summarize findings, compare methodologies, and organize evidence from the research paper. And all this significantly reduces your time spent manually in screening out the literature. You got your research network from Research Rabbit. Next point would be to use the software in order to get out those themes. What are the kind of claims that have been made? What is the kind of output that has been coming? You define out your parameters and you get the key insights. The AI does the job for you. So basically, what we would have achieved reading 10 papers in 10 days, maybe, or let's say a fast reader in 5 days, AI does it for you in 5 seconds. Similarly, there's another tool known as Consensus. This is a very interesting tool. It's an AI-powered academic search platform. Its strength lies in identifying the parameters of agreement and disagreement across the peer-reviewed studies. So rather than giving a single answer, it will help you to understand the broader scientific consensus around your own topic. And it will give you, okay, you produce out the parameters. Firstly, you put out what are the range shifts. For instance, let's take this example. It talks about our range shifts in forest caused by climate change. So first, at the first screening level, you got yes, possibly no, your answers, okay, where the consensus lies. And then deep dive into it. What are those papers that that are into agreement to my topic? What are the papers that are into disagreement into my topic? What are the kind of citations, where the region and the context is. For instance, currently as I'm working with a climate change project, it helps me to understand a certain kind of a question, let's say being asked around the world. What is the context in the West? How people are perceiving the same kind of topic into the East and the publications that have come out. What kind of authors are there? Maybe agriculture scientists or environmental scientists, agriculture scientists, people who are working with environment, they have a very different kind of a shift towards this topic. People who are working towards the engineering side, people who are working towards the social psychological side, it can help you to find the consensus among these categories as well. So once you have understood what kind of problem is in and around the topic of research, the next step becomes your conceptual framing partners. I understood. All these tools gave me, this is where my problem lies. This is what major research domain is talking about. This is going to be my focus on to. The next question becomes, how expressive and particularly effective are you at restructuring these broad and ambiguous ideas into a certain analytical framework? And AI can help you to do that. For example, a vague research interest can be transformed into either variables, it can be transformed into some measurable indicators that might be helpful for your research. You can have developed certain kind of conceptual models or any structured methodologies. And GPT-4o like OpenAI, Perplexity, Cloud, all these help you to do that. And as I said, you need to put in the right kind of structure while framing out your questions onto it. If you have the right responses from the earlier tools and you have formulated something on your own, okay, this is where my research interest lies and my research question needs to be developed into this direction, these tools, these language processing tools can help you to give a very precise, meaningful, and rigorous research question. However, it's your own responsibility to validate the relevance and contextual appropriateness of the research question given by the AI. It can organize the thinking. It like AI can give you an organized thinking, but it cannot replace your disciplinary expertise that you only have because AI takes from a lot of different perspectives. So that is where your human intelligence works out in the final proposition of framing a conceptual research question to your research topic. And because of this, there's also a need of specifically this tool to the architecture. It's an Autodesk style GPT tool. So what it does for you is it helps you to move beyond the generic language to some spatial logic. So we have literature review as one of the pioneers to give a basic framework to a research question. But what if you had certain case studies with you? These are specialized models that can integrate domain-specific constraints. For instance, you wanted to work around site yield, you wanted to work around your research topic on massing. You just need to give into those case studies and a research prototype coupling with the language mass with optimization will help you to build out what text to building design needs to go in. You say in my scenario, this ratio needs to be there. Generate out certain scenarios from your case studies, input it with your literature review and produce out the best of research questions. For instance, usually towards the end you want to see the optimization of one or the other kind in your research. These kind of tools help you to do that very initially in your research, and they help you to understand the feasibility analysis so that you know, okay, my research, is it a feasible one or not? Whatever I'm thinking in terms of producing out as my final output, it might give you a glimpse of what kind of scenario building can happen and eventually what kind of results you might get over the course of your journey. So because of these tools, AI efficiency gains like anything. It dramatically reduces the time that is required for any kind of an analytical task. But efficiency is not only about speed, right? It also is about the broader exploration. And that only comes when you have a good literature review with you. AI helps you to do that 85% faster than what we can do. If you have good code extraction from certain papers or something you have not able to understand, you put it out there in LLM or any other AI tools, and they help you to extract out certain kind of themes and simultaneously providing you brief synthesis of what the research domain is currently talking about. So when these things help you to save time, you can actually put those time in testing more scenarios, in comparing more variables and evaluating more alternatives than traditionally you would have got the time to do. So you are trying to reduce the first half of your research time through these tools where you can actually explore out in gaining other scenarios, in building out different alternatives, in trying to develop your project into a direction which can look upon into different directions, different parameters. Now, this is again supported, once you are done with your research question, it's supported with the data collection aspect, the stage 2 of any research. I'm going to go very briefly touching upon to these stages because otherwise the time might be less to talk about all kind of tools that are out there. So stage 2, traditionally our architectural research relied heavily on manual surveys and observational methods. Either you go to the site, observe few things, collect certain data, you do certain surveys, and that still needs to exist today itself. But with the emerging technologies, and fundamentally they are expanding onto a different scale, precision and temporal depth of data collection drastically changes when you utilize the AI tools that are there at your disposal. We are now able to collect spatial, environmental, behavioral, and even infrastructural data in real time. It's not that we had gone to the site in a certain month and certain year. The data becomes redundant nowadays. As they say, data is like oxygen of today's world. So whatever data I would have collected, maybe let's say 5-6 months back or a year back, till the time I reach to my data analysis and final proposal, it gets redundant. But if we are using these kind of real-time tools, they intend to support us in many different ways. For instance, we have Google Earth Engine, you have ArcGIS, you have QGIS. People are working around it with so many data layer sets, and they help you to produce out land use mapping, urban sprawl analysis, flood vulnerability mapping, walkability assessments. And this is something you guys are able to do in real time because of the input into the real time. The connection, the plugins from the Google Earth Engine, from Ladybug tools, there are climate studios, the data is real time. So even if like you take out that data after 3-4 months, there might be a certain kind of a change and you can report it in your findings. It's not like the whole research needs to change around it. But yes, it makes your research more iterative till the time you have your final solution. Let's take for the example, let's say environmental data collection. These are some of the tools that we use like Ladybug tools, Climate Studio, IoT sensors, and they can help you to do daylight analysis, thermal comfort monitoring, air quality measurement. Earlier, we used to have hardware that we used to go on site, work around with, look for the earlier data that might have been published in and around that building, or the contextual understanding of that area. And from that, we used to deduce out and give out certain kind of uh, data set that, okay, it's intuitive. It's not predictive, it's intuitive that over the course of years, this is how the thermal comfort of the area has been. I did a manual survey from people. They used to feel like this during this month of the year. Let's say maybe after 2-3 months, you go into the 4 seasons and collect out the data. It specifically saves you time on these aspects. You have ready to move in data whenever you want to put it, and your manual surveys can actually support out the comfort, the human psychology of the people can support out whatever environmental data you have with you. Let's talk about another example of human behavior and mobility data. So this is a space syntax of a space. Here we are doing a project known as Health and Housing Project. We want to see over the course of years, a certain housing was built for a certain purpose. But the user has changed, the climatic conditions have changed, the space movement around that building has changed. So how does the space syntax work? One aspect can be I might have the plans with me, I'll go to the area, I'll map around what is happening there, and maybe after 3-4 months I go again and there is certain kind of a change, I map it out again, and I have 3-4 maps of to that space. But with the mobile GPS data sets and social media geotagging, where we usually use the sentiment analysis of the people, we can have a real-time AI data set onto the crowd flow analysis and how the public space usage pattern happens. Space syntax, not only on the urban scale, but also at a very a brief housing scale can be done as well if you have the right kind of input set. And similarly, nowadays we also have so many tools to develop onto the built environment documentation. You have drone mapping, you have BIM platforms. The data is out there. You can work around. Even with the ArcGIS, there are so many plugins that can be utilized to actually help you evaluate the mass flow of the building, FSI, FAR, what is how the wind circulation of the area is, which kind of a building needs to come on, which kind of plot, what is the height onto it. So it helps you to understand heritage documentation, site scanning, 3D urban modeling. These are the kind of tools that are being used now into our sister countries in Asia. Singapore is one of the leading examples. Even China nowadays have a lot of data onto their platforms, where redevelopment of a certain area or redevelopment of a building, you don't need to do those manual surveys. You have data set from over 30 years, or let's say more than 4 decades of an data set available to you. Just run out the scenarios and you'll be able to find out your built environment analysis, how that works. So the data collection here becomes pretty easy when you are technologically literate to understand these AI tools and work along with them. However, collecting data is only the first step. We understood what our research question was, what our research domain was, how things were happening. We collected the data onto it. The real value emerges when computational systems begin extracting patterns and intelligence from that data. So, data right now is no longer scarce. Interpretation is the real challenge here. So much of data available in and around us. How do we actually justify which is the right amount of data and which is the right data for our research? How do we extract out patterns from it? How do we cluster that data becomes more important. So AI reduces those technical barriers. Uh, for instance, I'm a non-coder. I belong to architecture background and planning background. I don't know any coding, but I can still interrogate data with the coding aspect because AI has helped me. It already has inbuilt Python capacity to it, and I can work forward with it. So data analysis thus becomes important for researchers when you have to identify pattern detection. Okay, there are certain reoccurring spatial configuration and urban morphologies from all the data that was being collected and put into a certain data set or any AI tool that was giving you those data sets. Now I need to cluster around what are my grouping. Either it's building typologies or my energy profiles, or some kind of a new thing that you have learned while collecting out that data. So the clustering becomes important. And lastly, the prediction, so that you can forecast how these shifts would be there, how the future urban expansion might happen, how post-occupancy thermal comfort might be, using the regressive models that are trained on to work with these kind of data. So data analysis helps you out there. Let's see some of these tools. First one being Python for machine learning. We all know Python is a language for machine learning. SPSS, they all have Python as their machine learning language. So the backbone for any predictive modeling libraries like GeoPandas, as you can see here, and Scikit-learn is one other example. They allow researcher to bridge the gap between GIS data and generative design. So, for instance, the application of these in architecture could be you can get hold of climate vulnerability prediction. You might find urban pattern, some kind of an urban pattern recognition. You can have environmental simulations and certain kind of workflows that can be developed that bridge the data science and the spatial design research. We understand Python only from the research language of computational design, but that's not the only thing. It can actually help with these kind of AI tools like GeoPandas. R. R we have all learned in our research journey as one of the regression tool analysis for statistics. But very few of us know that R also works for spatial statistics. It can help you to produce out. For example, this is one of the examples where we had used are for computational regression analysis. We had to do correlation analysis. We wanted to do certain clustering, spatial autocorrelation. So for example, we classified neighborhoods using the socio-spatial indicators. And we provided, okay, so these are the social economic indicators and these are the social spatial indicators for the area. Now we want to evaluate the relationship between environmental perception and demographic variables. For instance, a person so and so educated, a person in so and so age group understands environmental perception in this kind of a parameter. So all these kind of inputs were given into R. The goal was not just this visualization that we were able to achieve, but in also uncover those spatial relations that observe that otherwise it would have been difficult for us to see, because you're working with, let's say, 2000 3000 data sets of an area. So those are, and then just like dividing out and gentrifying them into different education, age group, etc. And on the other hand, you have your own parameters that you need to work in around. So think of it as like match the column. Let's say age group, youngsters, what kind of parameter is something working for them in the environmental comfort of that area, and where does the mean median lies. So that's where R can also help you to work with the spatial correlation. And lastly, in the data analysis is the Power BI. Power BI is something where communication becomes important in research and it supports that. So it helps you to move beyond from those very redundant pie charts, bar graphs that you represent your data analysis, and it helps you to present them into this matrix of dashboards where you can link out your feasibility KPIs, where you can link your performance data to different parameters you want to attach onto. While I was completing out my PhD and I wanted to create something of this, we had a lot of data accumulated with us in many different areas of SDGs. And we wanted to find out, just as what we had done in R, that if I produce out this filter of age, gender, education, or some other socio-economical or some other socio-economical variable, I wanted to find out what are the indicators of which are the problem areas lying within these socio-demographic groups. Organizing that data is helpful here in Power BI. You can produce out these dashboards, present out in your research, and they are very good tools to actually represent whatever you are trying to convey out from the plethora of data that you have got and analyzed. Now, stage 4 is something very specific to architectural research. Usually after data analysis, we intend to go on to our proposals, merge everything together. But in architecture, there is one more stage of design exploration. Many people, they work with generative designs. They want to understand performance optimization. Some kind of scenario simulation needs to be made. And all this is done to understand the feasibility of your own study. For instance, instead of like manually generating design options, computational systems can produce thousands of these optimized operational alternatives based on whatever performance criteria you give it to them. And these performance criteria can be either daylight, energy efficiency, circulation, density, cost optimization. So design now becomes like a search process if you give a very appropriate parameter to it. And that's where generative design you would hear a lot nowadays in architectural research. So recent advances in the Gen AI technologies have been significantly driven by different data model tools. Although architects recognize the potential of these generative AI, the personal barriers often restrict them to their access to the technological developments. For instance, we intend to lag behind because we do not have the technological literacy to understand these Gen AI. So hence it becomes important for us to first learn and be in progress to what the field or where the field is moving on to. It becomes very important. Otherwise, we might be left behind. And it's not because we're saying AI is taking over things. No, but we are not able to learn how to actually regulate and work with AI. That's where generative design can help you onto anything. And this is something actually that should be in the architectural education as well. We have started incorporating these things into architectural studios, giving out the right prompts into the AI, working around with the mid journey, TAL, D-stable diffusion, these different models. Students are able to generate so many options, and they can actually see where these different matrix, where my design changes, on what parameters it is changing, and it helps them to actually save time on producing out so many alternatives, and at the same time increasing their time on enhancing their design and conceptual development. Because once your concepts are very rigor and you have understood how my spatial development would work around in my building, other than that, you just need to put out your parameters and they will help you to design out the new buildings. So in this, the one of the tool is generative design theory is the Autodesk Firma. Autodesk Firma is one of the AI generated tools of Autodesk. It helps you to have these generative design and environmental analysis platform. You can put into your design into the urban context area. It helps you to design rapidly, test the urban massing around your area, environmental performance, site feasibility, it can give you that. And the platform also supports evidence-based early stage design decisions using certain simulation-driven workflows. So what you can see on the right are these different parameters that the tool provides you. You just need to input out your building, and it can give you an initial potential analysis of how your building would sit into a certain site, or how its performance will be impacted because of the context of the site. Similarly, Grasshopper, we all know it's being used extensively in BIM for parametric and computational design, but it also allows designers and researchers to create certain rules. It's a rule-based system where geometry will respond dynamically to the parameters you have set. So understanding these integrations, Grasshopper, you need to put in those parameters, you need to put in those rules of how my geometry of a certain building should be in and around with my site context. So Grasshopper then can become a laboratory experiment for you. You can do so many experimentations that can help you produce out new optimizations. Certain performance-driven design explorations can be done. So this is another extension to the Grasshopper AI tool that we can work along with. Moving on to the last stage from design exploration is the visualization and representations. Now, done and dusted. We have understood our research. We have framed a very nice research problem from our language processing models. Our tool supported us to collect very efficient data, very real-time data to us, and we were able to analyze them with the support of so many different spatial, computational, and statistical tools. We understood how our design exploration worked, but this is a place where many of us fail in representation and visualizing how my output needs to go forward with. So visualization today is no longer just presentation of your final output. It has become more a part of the thinking process itself. AI tools can now support, as you all know, conceptual rendering. Students are doing it's not a Midjourney or ChatGPT thing that you produce out certain scenarios. These are tools that actually support conceptual rendering. Immersive storytelling can be done through these tools, data visualization, of course, and certain kind of a speculative representation of how my final product might look like. So visual outputs, they are increasingly become more functional rather than the decorative additions that we put towards the end. And let's look at them one by one. This is Veras. It's done by a company called Chaos, who are software developers. So this AI visualization works directly with your BIM workflows. It transforms your basic geometric models into these photorealistic conceptual drawings. From different angles and views, you can help explore your materiality. You can explore the lighting onto your product. You can explore atmosphere, spatial perception in the very early stages of your design. So this is, we are moving towards our final design formulation. So this tool actually helps you to produce and work around in real time. The next being Test Fit AI. This is again Autodesk plugin, works with Tile GPT of Autodesk Forma. It visualizes feasibility in real time. Understanding everything, I had developed out certain options and scenarios. Now you can instantly evaluate your floor area ratios through this, parking requirements, my density, my housing configurations, and it can also transform your abstract zoning and planning regulations into a very spatially understandable output to the jury itself. So when I'm producing out my research output and someone questions me, you could have done this, but not that. Rather than putting it into your limitations or the scope part of the research, this tool can actually help you to justify. I tried doing it, but this was these constraints were there, and I tried to change out the build height. I tried to change out the FAR, or my area zoning did not work around it. This was not allowed. So this becomes my best model that I take out from my final data analysis. Similarly is Hyper. It's a cloud-based generative design platform, and it enables you to build custom computational workflow and analyze large number of design iterations simultaneously. So what it does is, it's usually helpful when you have to do a performance-driven research, or you have a very system level analysis that my indoor residential indoor air, or let's say you're talking about thermal comfort, or it is about certain kind of design capacity of the building. Total units in the building should be this much and that much, and how does it impact my residential quality of life in the area, how my common areas are placed, how my spatial design can change out the urban context in and around my building. So Hyper helps you to do that. And you can also work with structure analysis in this software. That's the beauty of it. There are certain structural components that you might want to integrate, and specifically people who are working on research projects that align with GRIHA, LEED, certain kind of environmental parameters, and these accreditations and certifications. The different iterations of those sorts can actually help you to give out, okay, is this a silver rated building, platinum rated building, etc. And lastly comes the NVIDIA Omniverse. Now, for this tool, it's a real-time, actually, it's a digital twin environment tool, more than a generative AI. So you can visualize and stimulate different architectural system within the virtual environment. And it's a collaborative tool, mind you. Usually it's used in architectural offices where they're working with MEP, facade engineers, where they're working with thermal comforts, landscape architect, someone is working on the urban design areas. They can try to collaboratively visualize and simulate which architectural system would work best with my building in this urban context. And this is helpful because you have at times a lot of complex urban simulations and industry collaborations. Architecture is not just one discipline in itself. Even when we go into the field, we work with all these different consultants. So this is a kind of a tool that helps you to work collaboratively while simultaneously putting out the parameters and working in real-time scenarios, rather than changing what came from the MEP. Change your facade, and then once your facade was changed, the landscape came and said, no, this doesn't work, it needs to be changed like this, it's not working for my aspect. That kind of time is reduced while we use these different tools. So moving towards the end of my presentation, whatever we saw today, I would say there are few things that we cannot compete onto with AI. The first one being speed. AI excels at speed. tasks that traditionally took weeks, months, and years are now performed in minutes or seconds. There is no denial onto that fact. For example, environmental simulations, orientation studies, thermal analysis, all these were tested over the course of months and years. But now, because of the heavily set of data that is available in and around, we can test these things rapidly across thousands of scenarios. So speed definitely something that AI supports in architectural research. The next one being scale. As researchers, we usually have a scope. Either at a local level we are working, at a building level, let's say start with the building level, at the neighborhood level, going on to the city level, and then across few cities, different case studies are being done. Environment studies are done on urban scape, landscape levels. So AI helps to perform extremely well at scale. It can help us to process satellite imagery, urban data sets that are already being captured and worked around in your domain, survey responses, and GIS layers that are there across the entire cities, and you're working on all these data sets simultaneously. That what AI can help you to do. And this becomes particularly useful for urban research and where you have a large scale urban investigation into place. Next thing that AI does well is pattern recognition. Now we would feel that this is the strongest capability of a researcher. This is what we all want to do actually when we have our data. What patterns emerge from my research? And trying to recognize how my clusters are formed around those patterns. But AI can identify those relationships and anomalies that may not be visible just through conventional analysis that we are doing. For example, you want to find correlation between urban form and walkability. Imagine the amount of data you would have to collect, and imagine the amount of data you would have to collect at different point of time, on different days of the week, in different for different age group. Because urban form and walkability, it's such a broad topic, and how do I find out what kind of patterns might emerge? Is it age group related? Is it user related? Is it because of the urban context? Is it because of the landscape? All these things together and can be worked out in few minutes by AI if you put in the right data set to it, or we have the right data set from such a vast network of data system. Then unusual heat patterns can be detected as one of an example, or certain kind of a behavioral trends in public space usage. For instance, there's an AI tool that works with sentiment analysis. Sentiment analysis is nothing. Let's say we all use Facebook, Insta. There are many areas where people are very active in posting out the issues in their own neighborhoods, or something would have come up in news. So sentiment analysis, all the sentiments of the people from different platforms you're taking in, AI understands how it is happening, and AI also understands the measurable indicators for the urban environment that you had put in, and it can give you a pattern recognition where the issue lies. But as all good things work well, technology always has a limitation, and limitation of the AI specifically lies where we have to talk about lived experiences. We can support and utilize these tools to produce out good outputs for our research, but at the same time, your lived experience matters. Your human experience, human touch to the kind of data that has come out does matter, and you might want to change the iterations and scenarios we were trying to talk around with AI. It's us who is giving in the input for changing out those scenarios, because we feel no, this is not the right thermal comfort, this is not the right amount of daylight we are thinking it might come. The contextual judgment, because humans as a social animal understand context like no other. So the contextual judgment becomes very important, specifically when you are trying to input a certain set of data into AI. Your spatial empathy, AI is just data and something that can be measured, something that is non-measurable, something that is qualitative in a psychological and sociological way is your own spatial empathy. Okay, this is what the technology has given me or the best solution that it has given me, but still you might have your own points through your spatial empathy to talk about and change your design onto or discuss or maybe improve it further. And lastly is your cultural understanding. Over the course of so many years, through your learning, through your observation in the society, through your observation in the urban scale, your cultural understanding stands on the very next level of AI. AI is nowhere near to it. So these are few things that come across as the limitations for the AI. And as we end towards this presentation, I would say AI will not design better buildings. If initially when we said that it's not human versus AI, it's human intelligence augmented by computational intelligence, this is what exactly I meant, that AI will not design better buildings, but it will demand better thinking from architects. The best of the parameters you give, the sharpest of the questions you ask to AI, and the best technical literacy that you present to these AI tools will help you to actually give better designs for your own research. The future researcher will need to combine disciplinary depth of yours, your ethical judgment, your computational literacy, and critical thinking while working with the AI in architectural research. So technology will continuously keep evolving and more so rapidly, but meaningful research will still depend on human interpretation and responsibility. And that's where I would end this FDP session. Thank you.
Thank you so much, ma'am, for your insightful and thought-provoking session on the role of AI and data analytics in architectural research. Your perspectives on balancing technological advancements with human-centric, architectural thinking were specifically inspiring and intellectually enriching for all the audience and participants that are present over here. Now, I would request all the participants, those who have any questions or any key points of discussions, the floor is open. You could please switch on your microphones and ask the questions or any points of discussions with the speaker. We have one question.
Good afternoon, Niharika. Thank you
Good
for
afternoon, ma'am.
the presentation. It was wonderful, and we definitely have come to know about some new tools and softwares, which I hope we are able to explore further and apply. Your last present point was actually about the lack of integration of experiential data, right? And which is absolutely right, and it's necessary in architecture. My question actually pertains to the a strict or the pure research methodological approach. We talk about principles of reliability, adequacy, and validity, right? However, AI produces iterative responses and it changes. So how do we, how do you see this aspect of reliability being addressed when we use AI tools? And do you think is AI just for data collection, analysis, as you were just discussing, or can it actually work as a authentic research tool, because of the puritanical way of how research has to be addressed?
Thank you, ma'am, for the question. It's actually a very valid question right now and a debatable one in the field itself, I would say. So what happens with AI is definitely, as we talked, it can produce these iterative scenarios and the data collection and analysis. But where AI struggles currently is with embodying the human experience. So when we say, is the data that has come out from the use of these AI tools valid or reliable enough because of the iterative process that it has taken up? I would say we need to use it still very passively because they're deeply, for us, our human experience and how we put into the conceptual aspects of the AI still remain deeply contextual and subjective. AI can only analyze measurable proxies. So if I have to talk about data reliability, that segment lies onto human judgment, human experience. But yes, if I have to talk about data validity, AI does that perfectly because it works on measurable proximities, and data validity is only being justified through your measurable indicators and variables that AI is able to give you, such as, let's say, light, some kind of an acoustic, some kind of a movement or behavior pattern that you would have input. But its interpretation requires human perception, and that is where the question of AI's role in terms of data reliability works. How reliable it is. It's reliable, it's valid because it had input these data sets and it gave me the perfect answer to my question. But its reliability still relies on my judgment. And that's where uh, it's very early to say that AI will anytime supersede human experience, or let's say it's in competition with us. It cannot be. It's just a tool. Just like there was a time when from CAD to BIM the things were happening, and everyone was concerned for the safety, like what will happen. CAD we were able to at least understand, but BIM will do things on its own. But still, the interpretation is on us. So I believe that's how this will be in the field. Maybe a day might come that it might exceed our expectations and also work with providing certain reliable experiences and reliable outputs. But yes, reliability for the AI can be measured in continuation with its validity, but not entirely. It needs that human interpretation as of now.
Thank you very much.
Yeah,
Thank
I have
you,
a
ma'am.
question, Niharika.
Yes.
This is Sanjita this side.
Hi, ma'am.
Thank you, Snigdha. Hi, very good platform for a discussion with you guys. Feeling like home, nostalgic very much. So my question is, Niharika, in continuation with the previous question only,
Mm.
that you told that data measuring is accurate, but currently we are working on a UD project, or if it's research oriented, it is design based. So
Mm.
even the kids, they are measuring or the putting the data correctly, the AI generation, the input that is coming from AI is not accurate.
Right.
Sections is not proper, and they are using this AI tool. Then what is your take in that design approach? Specifically, if it is not theoretical, it is
Mm.
design oriented.
Mm. Okay. Yes, ma'am. Actually, this is the biggest issue in terms of using AI. As I said, even with the smallest of, let's say, putting out a small prompt on ChatGPT, sometimes it might give you the right thing. Sometimes you're just frustrated with what is the kind of response it's giving. Similarly, it works with these AI tools. If it's not giving out the right sections, if it's not able to produce out the right renders, then that means the student has not actually grabbed on the conceptual or spatial design intellect. If they have a very strong hold of their own conceptual spatial thinking before actually relying onto these automative tools, then only the AI can work wonders for you. Because AI in itself needs to have a very clear understanding of what you need from it. Right. So that is where the issue is currently, and I feel as we move forward in architectural education, it's a pedagogical approach rather than looking it towards technological aspect. I would say it's more of a pedagogical approach. Moving too fast with these AI tools without first understanding the foundation of your conceptual thinking, your design thinking, your spatial thinking, and you put out certain, like, this section needs to be produced as an output and this is what I want. AI won't be able to give you the right answer. So I feel it's
I think
more, yeah.
I think you are correct, because design approach need much to be modified in AI tools, and as
Exactly.
similar to BIM, because BIM
Yeah.
is more practical, but design AI has to be worked on upon, and architects need not to be afraid with AI. I don't think we
Yes,
should be
exactly.
afraid of it.
It's just like a tool, just like how we are all using Zoom for this platform, how we use PowerPoint, and we learned these softwares. Similarly, it's AI. These are
Yeah.
different tools you need to learn with and
Okay.
work
Thank
with.
you so
Yeah.
much. It
Thank
was
you,
a
ma'am.
very interactive session. Thank you.
Thank you, ma'am.
So much, ma'am. Do we have any other questions? Yes, sir.
Hello, good afternoon, Dr. Niharika. Am I visible to you?
Yes, sir. Yes, sir. I can see it.
Yeah, okay. Thank you for the wonderful presentation. Since AI is also evolving, and so are the researchers, and even the consultancy is also using AI very much. So, in your limitations, in your last slides, you have mentioned about ethics of AI, because there is a thin line between ethics as well as using the right tool for right research and putting it as it is. So, can you draw some more light on it, that how these outputs of AI, be it design, be it research, be it consultancy, or whatsoever, how the researchers can refine these outputs with their own needs, with their own requirements, and avoid being penalized for the ethical misuse of AI?
Right. So first of all, so whatever the AI tools they are using, and in terms of ethics, if I consider, there is a certain demand, first of all, in terms of research, if you're putting it and using certain AI tool, just like how we say that you refer to a literature or you refer to a research paper, you put out the citation. That's ethical aspect to it, right? I have referred to this paper and I have referred to this so and so author and so paper. Similarly, for the AI, whenever we have our limitation sections or scope section, clearly it needs to mention that these tools have been used. This is the limitation of the tool, and my expertise lies onto these points. For instance, we cannot say that I had created this, like this is I was the coder of whatever has been done here. I clearly need to put into the aspect that from my understanding, from my literature background, I found out certain parameters, and these parameters came mixed out from my literature, from the data analytics I got. And this tool, it was just a supportive tool to help me iterate these parameters and perform these different simulations. So ethics in these AI, even in design consultancies and research, if you would see the renderings that are produced right now, no no one mentions the software name or something, but definitely a small line comes in, it's an AI generated image. If it's an AI generated image, if it's an AI generated render, it is actually a no to put it as a terms and conditions somewhere near at the below, that it's an AI generated image and not the visual one, because there's a difference. The visual representation is something we used to produce from these rendering softwares, and it could have been used. We used to write not the real one, but the visual representation. That is where ethics, in terms of writing it correctly, what you are representing. So nowadays, it's people write it AI generated image and not the visual representation. So this is how, even with the ethics, there are a lot of legal frameworks that work. We work with government organizations that are using these data and putting it into AI. They have their own so many legal bylaws and so much of paperwork that goes into it, even to extract out data from them and work with these tools. So those ethics are taken care of with the design consultancies, and similarly, research in their thesis need to put it very explicitly. Otherwise, it's non-credible. Someone can just take out your data and say, okay, it was done through AI. So yeah, those things need to be out there.
Innovation is the key.
Yes.
Thank you. Thank you.
Thank you,
Thanks.
sir. Thank you so much, ma'am. Do we have any other questions? Thank you so much, ma'am, for your session today. And as we move forward, for all the participants, today's presentation was highlighting how architectural research in the current scenario is increasingly influenced by artificial intelligence, computational tools, and data-driven approaches as well, that help in analyzing spatial patterns, environmental performances, user behavior, urban systems with greater efficiency and accuracy. One of the key takeaways from Dr. Niharika's session I would like to point out was that AI should be seen as a support system for architectural thinking, perhaps, rather than, a replacement for human activity and sensitivity. While data analytics can process information and identify patterns at a very large scale, architecture ultimately remains connected to human experience, culture, memory, and emotion. The session also effectively emphasized the importance of balancing technological advancements with critical and contextual thinking. This interaction also moved forward with some question and answer round regarding the role of AI and data-driven research in understanding those experiential qualities of architecture. Another important discussion explored whether excessive dependency on AI could also gradually weaken the fundamental architectural thinking, ethics, and scope of usage in the submitted work. Now, these reflections made the session very enriching and highly relevant for researchers, educators, and students alike that are present today. Thank you so much, ma'am, for joining us and sharing your experiences as well.
Thank you so much for inviting me. Thank you.
I would like to invite Dr. Stigna Chaudhary to now conclude day 2 of our FDP.
Thank you, Lavdita. As we come to the close of the day 2 of this FDP, I would like to extend my sincere gratitude to all our esteemed faculty, speakers, participants, and support staff for making today's session enriching and engaging. The insightful discussions, knowledge sharing, and active participations throughout the day truly reflected our collective commitment towards academic excellence and continuous learning. We hope that the sessions conducted today have provided valuable perspectives and practical insights and new ideas that participants can further apply in their academic and research journey. A special thanks to our respected resource persons for dedicating their valuable times and sharing their valuable time and expertise with us. So with this, we conclude the session for day 2. We look forward to your continued participation in the upcoming sessions of the FDP. Thank you all once again and wishing everyone a pleasant evening ahead. Thank you.
Thank you.